Hi, my name is Jason with AlarmSystemStore.com, and in today's video I'm going to show you how to do the wiring for the DSC PowerSeries NEO. So I'm going to run through everything from the terminals on the control panel, how to put the control panel in the cabinet, through some various devices. And while I'm not going to show you everything, I will show you some examples of a lot of different things to give you a good idea on how to get started. So let's go ahead and go to the table and we'll get started with the control panel. So when you first unpack your DSC NEO, of course you'll have some other stuff as well, but one of the first things you're going to want to do is mount your NEO control panel board into the cabinet, and you'll use these little plastic standoffs to do that. It all comes with it. But before we do that for the video, I want to go, while we can see it better on the camera, I want to go over all the terminals here and just kind of go over what they're used for so that you can kind of see it better. So the first two things here is battery plus and battery minus, and then there's the two pin connectors there. This is where you're going to connect your backup battery. And then the next we'll see here is AC. So the first two terminals here are for AC power from your power transformer, and it shows the details of what you need up there at the top. But you'll just be hopefully using the power transformer you bought with the system. So the kits come with it. If you didn't get a kit, we do offer it as an option to add on when you buy the control panel itself. And of course there's no positive or negative there. It's alternating currents, so it doesn't matter black, red wire, whatever order you want to go with. So then we have auxiliary, this positive, negative. So this is DC auxiliary current. And you'll be using this to power things that require constant power, like motion detectors, glass break detectors, things like that. Then we have our bell terminal, positive, negative, and this is where you'll hook up your sirens. The next four terminals are the red, black, yellow, green terminals. This is your core bus. So this is where you'll connect keypads, you'll connect expansion modules, any other kind of modules you have will generally connect to your core bus. Next you have PGM. This is your programmable outputs, and then 1 and 2. If you have a 2064 or 2128, you'll actually have PGM 3 and 4 here as well. This is the 2032 model, so it's just got 1 and 2 built onto the control panel, and you can buy expansion boards to get more programmable outputs. This is where you'll connect, PGM 2 is where you'll connect to 2-wire smoke detectors if you're using them. Either PGM can be programmed to do a wide variety of things. Generally, smoke detectors for most people is all you're going to connect to these. So I'll go over some of that when we go through the wiring for smoke detectors. So then we have all of our zone terminals. So you'll see the first one is Z1, and then next to it is a COM. So Z1 and COM is where you're going to wire your Zone 1 initiating circuit into. And then next to that you have Z2 and then Z3. So Z2 and Z1 will actually share the COM terminal. The common terminals don't really determine which zone's going off, and just to make it easier, they've kind of, to cut down on terminals and things like that, each zone's going to share a COM with the zone next to it. So Zone 1, Zone 2 share this COM, Zone 3, Zone 4 share this COM, etc. And so it goes all the way to Zone 8. Again, if you have a 2032 or higher module NEO panel, you're going to have 8 zones on here. The 2016 will only have 6 zones, so it won't have Zone 7 or 8. Next to that is your ground. So you'd use this to ground the panel, help protect it from power surges and things like that. And then finally you have the dialer terminals, so ring tip R1 T1. So if you're connecting to a phone line, you'll definitely use ring tip, and depending on how you're wiring it up, you might use R1 T1 as well. So those are your main terminals. Most people will be using most of these terminals. There's also some other things on here: PC Link 1, PC Link 2. PC Link 2 may definitely be used if you have like a alarm.com communicator. You'll be wiring up to PC Link 2. But generally speaking, you probably won't use those. And if you will, you'll follow your manual for whatever you're connecting to these PC links. So now that we've gone over the terminals, the next thing we're going to do is mount the control panel into the cabinet. So you'll use 4 standoffs to do that, and the standoffs are pretty simple. They just you'll insert them through the back through some of these holes, and then there's 4 holes on the control panel that you'll put the standoff from. So it holds the panel off the metal cabinet. So the way that I always line this up is I'll actually take my control panel and I'll look and see which 4 holes it's going to use. So you can kind of line it up. You know, there's a couple different places you can line it up at. I usually use the top middle. Seems like the easiest for me. And so you can see lined up in all 4 spots. And so you can mark them, you can, however you want to figure out which one it is. So I know it's this one right here, so you just go in from the back and just push it in until it clicks into place. And then you can double check for the next hole, so that lines up there, and then this one lines up. So again, you'll go in from the back. It's hard to do when you're not looking at it. And it clicks into place. And then you do that for the other side as well. So it lines up with this one. And then you do the last one, which is this one right here. So now that you have them in the cabinet, you just want to carefully line this up, make sure that, because there's some wiggle room with those, make sure they're all in place. And then you just push pressure on there. It takes quite a bit, as long as you're holding it near where those 4 pressure points are, you're not going to hurt anything, and it'll click into place, and now you can't pull it off. If you ever need to take it off, there are kind of these barbs that you just take some needle nose pliers, push those in, and you can kind of work its way off. So now that we've got the control panel mounted into the board, the next thing we'll want to do is mount this on the wall. You'll probably already want the wires ran through if you're coming in through the wall, because you'll want to be able to slide them through this. So let's go over to the wall where we're going to put this, and we'll mount it up. So the first component I'm going to show you how to wire is the power transformer. This one has just the 2 posts, like you'll see with many of them. It's AC, so there's no positive, negative. You can hook up red wire, black wire, wherever you want. Some of them will have a 3rd post in the middle, and that's your ground post. So keep that in mind. Usually you'll just use your 2 outside ones. Those are your AC posts. And so I'm just going to use a regular 18 gauge wire, 2 conductor. It's got red and black. Doesn't matter which ones you use on which post. I can put black here, I can put red here. Doesn't matter. And then I've just got these little spade connectors on there to make it a little easier to connect. So I'll put one under there. Tighten that down. One under there. Tighten that down, and that's it. So let me get my next component here. Alright, the next device I'm going to show you how to wire is a keypad. So there's the keypad. You'll want to get a screwdriver and your 4-conductor wire, as well as your small screwdriver. The reason I have this bigger screwdriver, it's got this flathead tip on here, and it's a fairly thin, but you'll see at the bottom of the keypad here, of course ours is all dinged up because this has been open and closed so many times, and generally just using one of these screwdrivers because it's just our demo keypad. But to avoid damage, you'll want to put as big of a screwdriver as you can into one of these slots, just a flathead. And you can see this one fits just about perfect, same exact size. You put it in, and then you just want to pry up just like that. And you'll do that on both sides. And with the PowerSeries NEO keypads, compared to the older generation, they definitely use a lot thicker, stiffer plastic on this back plate. So it does take a decent amount of force to get that open. Once you do, you just fold it out. And there's a when a back plate is on here, you can see there's a little knockout right here. So that's where you'll want to put your wire through. And then on the keypad, you can see on the board we have a red, black, yellow, green terminals. And then there's a 5th one. This is for keypad zone. For this purpose of this video, we're just going to be using the red, black, yellow, green, which is your core bus wires. So take your 4-conductor wire, tighten that down. Black is next, then yellow, and finally green. Tighten that down, and then of course this will be mounted on the wall when you're actually installing the system, but you'd slide the keypad back in there and then it just snaps into place. And then you got your keypad wired. Alright, and then let's go to the next device here. So the next device I'm going to talk about is a Siren. This is just a regular SD15W from DSC. This is what will come in your kits, and it's very similar to most Sirens. So let's pop this back plate off. And you can see in here, it's got some wires, kind of a pigtail kind of here. So it's got black, red, yellow, 6 wires. Now, when you're wiring up, of course, as you've already seen on the control panel, there's a positive and negative for the bell output. So what do you need 6 wires for? Well, these Sirens actually have 2 tones. The black is your common wire, red is for a yelp tone, and yellow is for a steady tone. Now each Siren might be slightly different. It will usually come with a little piece of paper. For this one, it's actually printed on the back here. It shows you what's what. If you're unsure, you can always just take black to negative, red to positive directly on your battery. You'll hear what it sounds like. And then do yellow and black, and that'll show you as well. So if you're ever in doubt, it's an easy way to check. Now the reason there's 2 of each is because these will actually be wired in parallel with each other. So you'll have a black from the panel, and then if you have another Siren down the line, you're going to take black to that other Siren. So this just is an easy way to use your twist connectors however you want to connect these to your 18 gauge wire coming in. Connect black, and then do the same thing going to the wire on your next Siren. Same thing for your positive wire, whichever one you use. Now if you use red, you're going to use both reds. If you use yellow, you're going to use both yellows. And your next siren, you can switch. You don't have to stay on one, although most people will. So that one's pretty easy. Again, you'll connect your wires however you want. The easiest is with one of the twist kind. Let's get one rated for 18 gauge wire. So let's go to the next item here. The next device I'm going to show is a simple magnetic door contact, and this will be an example of just a 2-wire passive zone, so it doesn't require any power. So if you're not using resistors, you'll just plug in both wires into there, screw it down, and you're done. However, if you are using a resistor, you'll need to put the resistor in series with one of the wires. So you'll connect the resistor to the wire, and then the contact to the resistor, and then your other wire will connect to the contact. So if you want more information on resistors, what they do, etc., we do have a video that goes into depth on resistors, and really probably goes into more depth than you'll ever need. So the easiest way to connect your resistor to one of your wires is with one of these B connectors. It's just a crimp connector. You will line each of the wires up, and you'll just insert them into the connector. You don't want them sticking all the way through, but it's best to put them a decent way through. And with one of these crimp connectors, you actually don't even need to strip the wire at all, because it's got little spikes in there that will push through the shielding and will get to the bare wire even without doing any stripping of the wire. So you just crimp it down like that. I like to go over it a couple times, make sure it's tight, and then tug on it gently, make sure that both the resistor and the wire are in there securely. Then make sure that you have a good contact there. So once you have that, you're going to take your resistor and insert it into the contact, and this uses a Phillips, and then you just screw that down. Now with these small gauge wires and resistors, you don't need to go too tight or you'll potentially break the wire. But you do want to make sure that they are in there tight. So again, I'll usually tug on those gently, make sure that they're good. And with these, you just kind of fold it back, and then it's pretty easy to, go into the wall cavity with the whole wire, resistor, and everything, so that there's not much showing other than the contact. And like I said, for every 2-wire zone that doesn't require power, temperature switches, or sump pump switches, things like that, this same way you'll do it for all those. So let's put this to the side, and then we'll get out our next device. This is a motion detector. It's LC100 is the model of it, but this will be the same way for any powered device you have. So anything that requires a 4-wire connection, motion detectors, glass breaks, most common, and these are normally closed switches in almost every case. So let's open this one up. These can be tricky. There it goes. So on here, you'll see there's quite a few terminals. The main ones that we're going to be looking at for this are the 12 volts plus and minus, and then we have our common and normally closed. This one also has a few other terminals, but not every motion detector has those, so I'm just going to stick with our basic 4 ones: normally closed, common, and then 12 volt minus and plus. You can always refer to the manual if there's additional terminals, such as this normally open and T1, T2. So we'll start with the power. Now on this one, you knock out one of these holes in the back so that you can run your wires through there. I'm not going to bother doing that for this video. So we'll start with the positive, and this is a flat head, so we'll switch sides on my screwdriver here. And red, you'll always want to go to your positive, black will always go to your negative, that way you stay consistent. And then again, for these, it doesn't really matter which one goes to comm and which one goes to normally closed. I'm just gonna put my resistor into one of those, and yellow wire we're going to do to C. Tighten that down, and that's all there is to that. So then you'd close the case back up and move on to your next device. The last devices I'm going to show are smoke detectors. I've got 2 here. First one is a 2-wire and the second one is a 4-wire. The back plate here, it's pretty easy to mount this to your ceiling. You can check the manual on how to do that, and you'd of course run your wires through the back plate. For this video, I'm just going to set them to the side. So you can see that these look almost identical, with the exception of the terminals here. So for the 2-wire, you have 3 terminals. It's kind of a little counterintuitive, but the first 2 are positive, so positive, positive, and the third one is negative. So if this was your only sensor, you'd just be running a positive in and a negative in. If you had another sensor in line, you'd run a positive in, negative in, and then a positive out and a negative out. For the 2-wire, the alarm initiating circuit is the power circuit as well. It's shared on the same circuit. For the 4-wire, you have the same first 3 terminals, positive, positive, negative, but then you have your alarm initiating circuit, or the alarm relay. So normally open and common. Now these are normally open devices, so the last device in line for your zones are going to require resistors. So let's start with the 2-wire smoke. Grab my 2-conductor wire here. Now for this, even though it's a 2-wire connection, I am going to be using red and black. Reason for this is it's powered, so it's positive negative. It's easier to keep track that way. And then I'm also going to grab the resistor, so we'll act like this is our last 2-wire smoke in the line. Now with 2-wire smokes, you do need to make every 2-wire smoke on the same circuit in parallel. The resistor that is used is a red, 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 gold, which is 2.2K. So the 2.2K resistor, you'll set under positive and negative, just like that. And then you'll take your red wire to positive, tighten that down, and black wire to negative. Now you can see this is a little bit different than you saw with our just regular passive zones, normally closed zones. The difference is that with normally open, your resistor has to be in parallel instead of series. So it has to be across your 2 connections. So there you have your 2-wire, and again, this is what the last one in the circuit would look like. If this was not the last one, we wouldn't have the resistor here, and we'd have another black wire going to negative on the next 2-wire smoke, and we'd have another red wire going from this middle positive to the next 2-wire smoke. So let's set that one to the side and do our 4-wire. So the 4-wire also uses a resistor, and it's going to use just a regular zone resistor, the green, blue, red. And you're not going to put this on the power wires, you're going to put it under the alarm relay. And again, this is as if this is the last 4-wire smoke in the circuit. Now, one of the benefits of the 4-wire smoke detectors, you can run each one of these to a separate zone if you want. You can connect 2 on a zone, 2 on another zone, however you want to split these up. And then your power is still going to be in parallel, whether you're doing home runs or running one continuous parallel circuit, however you want to do it. So let's start with the power wire. So we're going to go positive with the red wire. Negative with the black wire. And then the green and yellow wires, doesn't really matter which order you do, because these are not polar. And just like that. So if you had another one in the circuit, you would not have the resistor, and you'd be going positive to positive, and you use this middle positive to go out. Negative to negative, normally open to normally open, COM to COM. Until you get to the end, in which case you'd put your resistor and you just have the 4 wires coming in, no wires going out. So that's it for the various devices. That should give you at least an example of kind of every type of device you'll have. This obviously isn't every kind of device you'll have, but it should give you a good idea on the wiring for those. So let's go ahead and move to the wall and we'll get finished. Alright, so I got the wires ran through the back of the panel, and then I've also put on these 3 plastic standoffs, and these are going to be for my Ozone Expander. So here's the Ozone Expander. You can see it's a smaller board, and it's going to fit right there on the panel. It's got 3 holes, 1, 2, and 3, that those plastic standoffs go through. And there's a couple other locations. You can put it down here, up here, and there's also a location on this side. So you can put multiple of these in this style cabinet. If you have the main board in here, you generally don't want to put more than maybe 2 at most in the main cabinet. And so let's just look real quick at some of these terminals. So starting on the left here, you have tamper plus, then auxiliary plus, and then red, and then black, yellow, green. So the red, black, yellow, green is your core bus. And then just like on the main panel, you have your 8 zones with the comms. So Z1 comm, Z2, Z3 comm, Z4, etc., all the way to zone 8 on the far right. So to put this in, just like the main control panel, you line up your standoffs with the holes and then just press. Clicks into place. And another thing to note, you want to make sure that your terminals are on the outside. If you put it in correctly, the holes only line up so that the terminals are on the outside. So whether you do it on this side or this side, it only lines up one way. So now I'm going to wire, start by wiring up our Ozone Expander first. So the first thing you want to do is you need to put a tamper wire in. So if you're using a cabinet tamper, you know, maybe this is connected to zones, but it's in its own cabinet, or you know, something like that. You can use a cabinet switch to wire to the tamper, And that way if somebody opens it, you get a trouble condition on the alarm system saying that there's a module tamper. If you don't use the tamper switch, you just need to put a jumper there. And so the jumper is going to go into tamper plus. And then it's going to go into black. And so if you hook it up like this with a jumper, you're not going to get that tamper. This is a common issue. People think, oh, I'm not using a tamper switch, I'll just leave it. But you get the tamper trouble condition because there's not a closed circuit there. So that's one thing to watch out for. So now that we have that in place, we're going to take just a short piece of wire and we're going to wire up the core bus. So nice thing about the core bus with standard alarm wire, it's you just follow the colors of the terminals, so red, black, yellow, green. Alright, there you have it. So then we have the other end of the wire here, which we'll wire up to the core bus on the main control panel. So I'm going to switch camera angles and do the rest of the wiring. Alright, so we'll start with our Ozone Expander since we already have the wire right here ready to go. And it just goes to your core bus. So red, black, yellow, green. Nothing too complex there. And so these don't need to be super tight like I was saying before. This kind of terminal block can easily break these wires if you get a little overzealous with it. So there's that wired up. Now you can wire these up in any order. I'm going to start on the left hand side here. So I'm going to find the one that I've labeled as AC. And these will just go into the AC terminals. Now remember that these are not polarized, so it doesn't matter positive, negative. Red and black can go to either one. Out of habit, I usually put red first and then black, but it doesn't matter at all. So then we have our bell right here. So you can see it's labeled bell. So this is going to go bell positive, negative. Now this one is, it's a DC circuit, so you do have a positive side and a negative side. If you don't wire it up right, it may not work right. And I'm always tugging on these just a little bit to make sure that they're in there. So then you just have to start going through your wires, and you can kind of see by this mess of wires here. And I don't even have that many wires, I'm just doing some examples. You could easily have twice as many wires or more coming into the main panel. If they're not labeled, it can be quite a task to figure out what's what. So hopefully whoever ran your wires labeled them. If they didn't, you'll just have a nice task before you. We are going to be, if the video is not already up, we should have a video up soon on how to determine where wires go. So hopefully that will be up when you see this. If not, it should be up soon. So here's one that says key. So this is my keypad. Keypads get wired to the core bus, red, black, yellow, green. So we'll start with red here. Another thing to note while I'm doing this is that you don't want to strip your wires too much. You can only put them so deep into these terminal blocks, so if you have a bunch of wires stripped, you know. I've seen them where people have them stripped so that they're like an inch long, bare copper. Those could easily cross over and short with something that you don't want it to short with. At the very least, it could cause your system not to work right, and worst case scenario, it'll cause serious damage to the equipment. Alright, so the key bus is wired up. Next thing we'll do, let's just move on to zone 1. So here's our zone 1. Now zone 1 is our door contact. So it's just a passive contact, it doesn't need the power, so we're going to get rid of red and black, just fold those over, and we'll just use these. Again, it doesn't matter really, yellow, you could go to Z1 or COM. The way I normally do it, and you don't have to do it this way, is yellow I do to Z1, so yellow to zone and green to COM. That's just the way I do it, and I like to stay consistent so that, you know, I'll do yellow to all my zones and green to all my COMs, but you don't have to do that. So now let's find zone 2 here. Alright, yeah, this one's zone 2, so I got Z2. And this one is our motion detector. So it's going to go to zone 2. We'll put the yellow wire in Z2. Our green wire into COM. And these share a common terminal. So you'll want to fit them both in there. Just like that. And this does require power, so we're going to run these two red and black to aux plus and aux minus. So if I can get it in there, aux plus, aux minus, just like that. Okay, so now next one we're going to do is our 2-wire smoke detector. So 2-wire smokes only have the positive and negative wires. They have no separate alarm relay or initiating circuit. So for this I'm just going to use my red and black. So red is actually going to go to aux plus. There we go. In black, always for a 2-wire smoke has to go to PGM2. PGM2 is the only PGM that allows you to use 2-wire smokes. So here's your smoke zone for the 2-wire. And then the last thing we have here is a 4-wire smoke. So 4-wire smoke detector has power wires and then the alarm relay. So the alarm relay we're going to run to zone 3, and I marked this as 4-wire just for the example. If I was doing this, I would actually probably label this with a zone number, and usually I'll label with a zone number as well as what the zone is, just so I don't have to look at a cheat sheet or something like that. I'm just dealing with 3 zones on this example, so it's pretty easy to remember what's what. But if you have 16 zones coming into the panel, it can be hard to remember which one's a door contact, which one's a power device, motion detector, glass break, whatever it is. Alright, so red wire is going to go to aux plus. Now you can start to see here how these terminals can get pretty crowded, and really if you are doing more than 3 wires, in my opinion, it starts to get kind of annoying. It's hard to get the wires in there. When you do get the wires in there, it's kind of hard to keep them all tight in there. To remedy this for aux plus and minus, as well as your key bus, because if you have multiple keypads, this can get pretty crowded pretty quick, especially when you start adding in other modules. The way to fix that is with a BT600. All this is a terminal expander. It'll basically take one of these terminals, you run a wire to the BT600, and then it'll expand that terminal out to 6 more terminals. So it gives you a lot of extra room to put in wires. And each BT600 has 2 sides, so you can run 2 terminals off one BT600. So if you're doing it for your aux plus and minus, that'll be 1 BT600. For your key bus, you'll probably want 2 BT600s. So generally, you know, if you have a decent sized system, getting 3 of those BT600s is probably a pretty good idea. It really helps clean up your wiring and makes things connect a lot better. They come with an adhesive pad, so you can stick it right to the side of the control panel if you want, or you can even get your own control panel kind of as a junction box, or however you want to do it. Alright, so the black wire for the 4-wire smoke, we're going to run to PGM1. It's only one smoke detector, so PGM1's got enough current to power it. And the reason you have to connect it to a PGM as opposed to just doing aux plus, aux minus, is your smoke detectors are a latched alarm. So whenever they detect smoke, it's going to latch and stay in an alarm state until the power is cycled to it. So if you have it wired up to aux plus, aux minus, you're just going to have to restart your whole system. So you're going to have to unplug the backup battery, unplug your AC, power the whole thing down, power it back up, and then you're going to have to reset your time. It's a pain, really. But if you have it connected to a PGM that's programmed as sensor reset, all you have to do is type in *72 on your keypad, and that turns the power off to that PGM type for 5 seconds and then powers it back up. So it's a lot easier than coming into the cabinet, taking off your backup battery, finding your AC transformer, unscrewing it from the wall outlet and pulling that out. It's a lot easier to do it with the PGM. So the last thing that we're going to hook up is our backup battery. I got one of the big ones here. So you can kind of put it wherever you want in the panel, or near the panel. Most of the times you're going to just want to put it inside, so if somebody's trying to tamper with your system, they can't just come in and unplug it. And as you can see, this is why you're probably only going to want to put 1 or 2 of your expansion boards in this cabinet, because once you add in this plus all your wires, it gets really messy. Of course, these wires I'd kind of push back through the wall to keep it as clean as possible in here. So here is the connector for the battery. It's got the pin side and then 2 spade connectors for the battery terminals. Now your battery is a DC voltage, so it's got a positive and negative side on the battery as well as the control panel. So you want to make sure you get that right. This pin connector and the spade connectors can easily be switched around. So just want to make sure you pay attention. It's nothing hard, but if you're not paying attention, it can be easy to mess up. So you just slide that on and it'll latch in place there. And then your spade connectors, they'll just go onto the battery here. And it's a tight fit, which is good. That's the way you want it, so that they don't just easily come right off there. So once that's on there, that's all the basic wiring for the alarm system. Now you might have a lot more wires, like I've been saying. You know, you might have all 8 zones. You might have a phone line connected to your tip and ring, possibly the R1T1, depending on how it's set up. You may have an expansion board in here, or maybe you have a alarm.com communicator, or you have an interface module, the PCL 422. But everything pretty much wires up just like this. This should kind of give you a good sense of how anything that we sell for the NEO wires in. So hopefully you've got a good idea on how to do all your wiring for your DSC PowerSeries NEO. If you liked the content of the video, be sure to hit the thumbs up button and subscribe to our channel for more videos like this. And you can also visit our website. We have lots of resources as well as equipment if you'd like to purchase anything. Thanks, and I'll see you in the next video.